Now we come across a truck and car example. That is, a truck starts from rest with an acceleration of 1.5 meters per second square. So acceleration is always given in meters per second square, and the car is 150 meters behind, starts from the rest with an acceleration of 2 meter per second square. So 2 meter per second square is the acceleration of car, and acceleration for truck, that is 1.5 meter per second square. How long will it take before both the truck and the car are side by side, and how much time or how much distance is traveled by each? To solve this question, we have to use the general equation of motion, that is distance covered by truck, with assumption that in the initial velocity is 0. So that will be half at square. So we have generated equation number 1, half, and for a we put the value, t square is unknown. Distance covered by car on overtake the truck. Again, it is SC, that is distance covered by car. It is half AT square. A is 2. So we again put the values, and we got the second equation, that is half of 2 into t square. Then we divided equation number 2 by 1, and we come to the conclusion that the value of ST plus 150 over ST, that is 2 over 1.5. Or otherwise, this number will be 4 over 3. ST is divided by ST, and 150 is divided by ST. So the function comes 1 plus 150 over ST. We put the values, and we will find that the number comes to be 4 over 3. Now, from 4 over 3, 1 is to be subtracted. We get 1 over 3. So ST will be 450 meters. Distance traveled by car is 450 plus 150, because car was behind the truck. So 450 and 150, that will give 600 meters. Now, by equation 1, ST is this much, half AT square. 450 is half into 1.5 into t square. And from this, we will get the value of t square, and hence the value of t, which comes to be 24.5 seconds. Therefore, car will overtake the truck after 24.5 seconds. So it is indicated in the figure that car is behind the truck, and the separation in their centers is 150 meters. Now, two cars are traveling towards each other. So they are moving towards each other on a straight road. The velocities are 10 meters per second and 12 meters per second. When they are 150 meters apart, both drivers apply their brakes, and each car decelerates at 2 meters per second square until it stops. How far apart will they be when they have both come to stop? So to solve this question, we make certain assumption. That is, x1 and x2 be the distance traveled by the car before they stop under deceleration. Using the formula v square minus u square is equal to 2as, or v square is equal to u square plus 2as, we compute the values and form two equations. One of the equations in terms of x1, other is in terms of x2. And by solving them, we get x1 as 25 meters and x2 as 36 meters. So, after calculating x1 and x2, the total distance is estimated, adding 25 and 36, and that gives the value of 61 meters. Now, distance between the two cars when they stop, 150 minus 6, that is 89 meters. Now, in the another question, a ball is thrown from the ground vertically, upwards. When anything is projected vertically up, velocity goes on decreasing, and at the highest point, velocity becomes 0. We are referring to final velocity. So, ball is thrown from ground vertically upwards, reaches the roof of the house 100 meters high. At the moment this ball was thrown vertically upward, another ball is dropped from rest vertically downward from the roof of the house. At which height from the ground do the balls pass each other, and after what time? So in the solution, we will find the two balls meet at the height h from the top of the house or at height 100 minus h from the bottom. The both statements are in accordance with the question first three lines. Let the balls meet after time t. Then for the ball moving down, the distance covered is or h is equal to half gt square. For the ball moving up, the equation is 100 minus h, that is equal to ut minus half gt square. So this is the second equation. Since the upgoing ball reaches to a height of 100 meter and its initial velocity will be 0. Now after putting the values in a given formula, then we get 1960 meter per second under root. From equation 1 and 2, 100 minus half of gt square, that is equal to ut minus half of gt square. So t is equal to 100 over u. Now put third equation in 1 and our conclusion will be after putting the values, h will be equal to 25 meters. Therefore, the height of their meeting point from the ground is 100 minus h, 75 meter, and that will meet after t, that is 100 over under root 1960 seconds. We can rationalize 1960 and we can come to the conclusion earlier. Now next question is, a body travels a distance of 2 meters in 2 seconds and 2.2 meters in next 4 seconds. What will be the velocity of the body at the end of 7th second from the start? So here in this case we find s is 2 meters, t is 2 seconds. Now in the case 2, s is 4.2 meter and t is 2.4, that 2 plus 0.2 plus 4 and that is 6s. U and A be the initial velocities and uniform acceleration. So we have to apply the formula, s is equal to ut plus half at square. Now in the first case, after putting the values, we will find that 2 is equal to u multiplied 2 plus half a2 square, and we get the value, that is u plus a is equal to 1. Similarly, in the case 2, we will get u plus 3a is equal to 0.7, and now we have to use the simultaneous equation in two variables to get the value of a and u. So we find that the values are calculated by subtracting 2 from 1. We get 0.3 is equal to 0 minus 2a, that is minus 2a, or a will be minus 0.3 over 2, that is minus 0.15. From first equation, u is equal to 1 minus a. We put the value of a and we calculate the value of u. u is 1.15 meter per second. And for the velocity of the body at the end of 7th second, we use the formula as nth is equal to u plus a over 2 into 2n minus 1. So we have u is equal to 1.15 meter per second, a, that is minus 15 meters per second square, v is to be estimated, t is 7 seconds. So we have to apply the formula, v is equal to u plus 80. Then we calculate the value of v, and that is found to be 0.1 meter per second. Now in the next example, a body travels a distance of 20 meters in 7th second and 24 meters in 9th second. How much distance shall we travel in 15th second? So we must know the formula that s nth is equal to u plus a over 2 into 2n minus 1, where n is a particular second. So S7 is given, S9 is given, and S15 is to be calculated. The formula to be applied is u plus a over 2 into 2n minus 1. Now first of all, we find the value of S7 by using the formula, then S9. After finding these values, we will mark them equation number 1 and 2. Now subtract 1 from second equation and we will come to conclusion, that is S15, that will be equal to 36 meters. U is calculated to be 7 meter per second. A person traveling at 43.2 kilometers an hour, then he applies the brakes, giving deceleration of 6 meter per second square to his scooter. How far will it travel before stopping? So what we will do, the person is traveling the car and deceleration is at the rate of 6 meter per second square. It means that when the body is moving, the brakes are applied, the retardation will be produced. How far will the travel before stopping? When this u is given, we convert it to meters per second by multiplying the number by 5 over 18. And deceleration, that is given 6 meter per second square, v is 0 because brakes are applied and finally it comes to rest. So final velocity will be 0. S is to be calculated using v square is equal to u square minus 2as. Now by computing the values, we'll come to this conclusion, it will be 12 meters. Now in this question, driver takes 0.20 second to apply the brakes. After he sees a need for it, this is called reaction time of the driver. If he is driving a car at the speed of 54 kilometers an hour and brakes cause a deceleration of 6 meters per second square, then find the distance traveled by the car after he sees the need to put the brakes on. So what exactly is the solution? Distance covered by the car during application of brakes. That is 54 kilometers an hour. It is converted to meters per second by multiplying it by 5 over 80. So S1 is UT or S1 is equal to, we will put the values 15 into 0.2 after applying brakes. So V is equal to 0, U is 15 meters per second, A is 6 meters per second square, S2B is to calculate it. So we use the equation V square minus U square is equal to 2GS, or V square is equal to U square plus 2AS. We compute the values and the value will come as 18.75 meters. So difference traveled by the car after driver sees the need for it, that is S is equal to S1 plus S2. So put up both the values and our conclusion will be 21.75 meters.